So the first example here is actually a collaboration I have with Romy. And so they did this really interesting work with the influenza virus. They did the full molecular dynamic of the full virus. And when I was talking with them, I was like, so how do you visualize this thing? Well, at the time, they couldn't. Like even VMD, you can open it in VMD, but you're not going to be able to play the trajectory or to interact with it. And so at the time, we were still working on cell view, and we were like, okay, maybe we can just read the trajectory and display it in real time with all the atoms and play around with it. And it appeared that if you correctly use a computer, your computer and the graphic card, you can actually do it. You can display millions and millions of spheres in real time and make them move, and with no latency. And so we did this application, and it's working really well. Now, you have to remember that this is just visualization. Like usually people that do molecular dynamics, they don't really care about visualization. They care more about, analyzing the conformation, the coordinate. But still, I mean, it's important to be able to have a look at it, because, on this model, we notice that actually one of the proteins on the surface is not correctly aligned to the surface, but is like tangled like this. And so if you just look at the coordinate, I don't think you can see it. You have to look at the full model to see, okay, there's a problem with this protein. She's like falling like a tree or something. Anyway, and since we are interested in dynamic, we were like, okay, so if I have a model and I have thousands of proteins, that's too many atoms to simulate. Like even the influenza, that's not a big system, that's small. Like if you think about Escherichia coli or the smallest bacteria in the world, which is Mycoplasma, that's still going to be 1,000 of proteins, and so billion of atoms. So we're not going to do molecular dynamic. And so what we were looking at is, can we do something really, really fast on the GPU, and that will be bit-based, like in coarse-grained simulation, where you replace atom, residue, or protein by bits. Can we do that on a GPU and really fast? And it appeared that some time ago, the company NVIDIA, they released this simulation tool called Flex. And it's designed for a game. But the interesting thing is, with this library, you can simulate up to 1 million of these small spheres, and it's going to be in real time. And it's going to, they're going to collide, and you can do spring, and that's quite interesting. So what we do is we started to just look at some DNA experiments, and then I'm going to show you later, but we can do actually like full cell, complete full cell. There you go. Like on the right, this is the flex representation. Everything is a sphere. And on the left, it's how it actually looked like with the atoms and the protein. And so that's what we're working on currently.